Hello? It is time. All right. Okay, so I just need to figure out why it looks like I'm doing nothing, and if anything, I'm making it stuff worse. Like, what is that, right? So, I'm gonna try to get, I guess I'll just get this first leg to try and do something. It's weird. It seems like some of the legs are normal, and then some of them are just not normal. Ooh. Okay. Maybe I should just do like this. Just run into it. All right, cool. I've got a very large displacement right now. So the idea is I should be able to see I guess I'll just be able to see what's going on here. So this would be leg 4. Joint, what would this be? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is that right? I have... You have 18 joints. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This will be index 14. So, I think I should just be able to skip until I see index 14. Okay, I'm going to start with this one. So I'm going to start looking to see what the errors are. Okay, this is just, no. I think it really wants to rework my music playlist. Some of these songs I just don't like anymore. I don't want to listen to them. But I also don't want to remove them because I think they're good. I don't know. Not fitting the mood. So I'm going to start by looking at the one before it. So this is going to be this joint right there. It doesn't look like it's really off at all. So it looks like it's should be normal. But I do have the parent transform. So this is where it should be. The idea is that this is where this should be the transform of the body itself. So I'll click joint data, body. This should be the transform of the body itself. Basis. Okay, so I see we're off by like a full centimeter. already. Hey, Yulia. Yep, there's a dog. Yeah, so I don't think these should be this far off immediately. This just doesn't seem right. So I mean, I guess I'll find. I mean, it should correct this. Like it should, by the end of this, rigid body should have the same transform as the parent. Okay, not the exact same transform. It'll start with the same transform, or at least the position. And then I should see... That one's kind of hard to tell anything. Yeah. Okay, so then bone position is just going to be that location relative to the skeleton, and then I need to get that location relative to the parent bone. Okay. Sure. So this is an IK joint, so I would call snap bone to rotation axis. Let's go in there. And what I expect to see is going to be like a little bit off. That doesn't seem like a little bit off. That seems like a lot of off. So I'm guessing the rotation axis is X. Yeah. That's off by a lot. When I'm moving the transforms, do I have to say, like... The thing is, I definitely made it worse. So something is happening. But also not. Okay, so that was like 2 centimeters. I mean, I guess it's like 2 centimeters out of like a meters, but I mean, that's a lot. That feels like too much. Okay, so we've got bone rotation. So it's going to rotate on the x-axis, which is exactly what I see. I just see a pure x-axis rotation. It's good. I compute the body's global transform. I think what I expect to see is that the X transform here should be identical, and then these two would be moved a little bit. Position should be identical too. So now I go look. So the x-axis is matching. And then, you know, there's just some rotation, so the other two axes are a little different. And then we have teleported to the right position. So I'm getting a bone rotation that is translated by its rest. So this bone rotation represented just a pure X rotation. Now it has all the stuff. And I expect to see last position and last rotation to be really close to the values I'm about to set. So last position, identical. Last rotation, this is very different. This looks very, very different. That is very, very different. Why is it so different? Oh, I understand why. Um, because of when this is running, I mean, at least, yeah, because of when this is running, this is actually just the rest pose. So when I get bone pose rotation, I'm actually just getting the rest pose because it's already been reset. This is just so I could see it. Okay. So that teleport works. So what I should see at this point is this parent transform when it changes on the next run. I should see it basically not move. It should be identical because I'm reading. Okay, no. It won't be identical. I'm going to be reading. Never mind. But I am getting the parent's global transform, which should be in this case the one that I just did. So body, so parent should be back left tibia. Yep, that's the one. And this one would be tarsus. Okay. I don't think it Oh, wait. Maybe it does matter. But the other thing is they're like the joints are like weird and slidey now. Why are they slidey? Why does the front left leg always bend in and this back right one just wobbles all over the place like this? Why? I'm thinking what I have to do is because of when this runs. Okay, I'm not gonna finish that thought. I'll be right back. back. Okay. I think I do. I think I do get it. Well, I'm just gonna check because what I should see is after I hit F4 or Control 4, just my keybind to go forward to physics stick. This should snap pretty much back to where the blue is. That's what should be happening. It should snap back to where the blue is. Where am I right now? So I'm getting this information. Okay. Parent transform, the current body is... I mean, that one's not so bad. Okay, it's off by more than a centimeter. I think the overall length of this is more than a centimeter off, which I don't think makes any sense. 1/100th of a second, 1 centimeter, that's 1 meter per second, which is... I mean, maybe it makes sense. But anyway, my suspicion is that I should be, where this runs is it runs from here. Integrate forces. This is the point at which, I believe, all the body state has been transferred to the physics server. That's my thought. So if I were to do something, I mean, I guess I need to verify. I'm not sure if modifying it here does anything, because it's technically running... I don't even know where I would look for this. I'm just looking for node, probably rigid body. Swap file, like, should I be deleting the swap file? Probably. Transform changed, if area, otherwise do body state transform, notification. So it looks like it's handled. My wonder is if I've been doing it wrong and I have to do like force update transform or something like that. But I am setting the global transform directly. If data notify local transform. Local transform changed. Notification local transform changed. Update configuration warnings. Notification transform changed. I have a feeling there's only a couple of these that even use this. I saw it. Force update transform. So is it not happening? So my thought there is... Yeah, so my thought there is setting the global transform doesn't cause this to happen. Which doesn't cause the body state to update. So here's a good way I can test this. After I set the global transform, I could then retrieve that transform. So I'm just going to run this and on a null. Okay, the first frame, it doesn't exist yet, so sure. I mean, probably I shouldn't be writing that out. This one's just too long to write out like that. Actually, I already see that this is really far off, isn't it? Alright, this is a huge displacement. So it should be that what I've done right now is that what I mean, I'm not entirely sure, but what I see right here is what I should like read back in. So I should read in like a massive displacement on join 14. Yeah. Just gonna wait till we get to 14. All right. Got joined 14. So I'm just gonna look at what its current data is relative to its parent. Whoa. So if this is global transform, this is like a big X and a little bit of a Z change. Yeah, the X is off by like 3 centimeters, so that's good. The Y is off by almost a centimeter, and the Z is off by 2 centimeters. So yeah, this is a massive displacement that I have, that I can see, and I have here. So the idea is I would run this, and I would, now it should be fixed to that location. The transform should be the same, and then this is an X thing, so the X-axis should match the parent. Yep. And then the other two can change a little bit. And then yeah, its position is updated correctly. So now my thought is, if I run this, this shouldn't force an update. So if this is not the same, then I know I have a problem. Okay, so I've now got body state transform. And in fact, I should even see that these line up already. Okay, they really do not. This has a completely different x-axis. Its position's not the same. Alright, that's what I was suspicious of. Yeah. See, this is what I think I've set it to, and this is what the physics server really thinks it is. Okay, good. Yeah, and these offsets are actually even worse. So, cool. So what I have to run there is after I call this, I need to call up force update transform, is what I should call. I could also directly access it, but it seems like the first frame it doesn't exist yet. So I'm just gonna call force update transform. That will just call it to set it on the physics server for me. It should come in as the result from the physics server, so I shouldn't need to worry about that. It's just getting it back out is the issue. And now it should be going back out. So now hopefully weird stuff is not happening. Alright, that's very weird. But it is interesting. It seems like I have an instability here, where on this frame the IK updates to go there, but then I'm teleporting here? Why would I teleport there? Because really all I'm doing is I'm taking... Wait, let me think about that. Okay, so bone position is supposed to be... No. Bone rotation... I'm getting the direction that it's pointing in. Why is the IK doing this? Because they are flipping back and forth. Okay, so this is the very last joint. And it's happening every frame. Very consistently. So I need to skip until I'm at 17. I must just have a mistake with how I'm... Somewhere around here I'm using the wrong value. So the parent transform right now globally wants to point that forward axis. Really? Oh, well, this is like the rest pose. So if I look at this, cool. The rest pose is kind of like 90 degrees off of this one, so it would be pointing a little bit down, right? So that's fine. And then I was just looking at this value here. So this says we're pointing slightly down. I was expecting it, if this was the problem, then this would be pointing really far down. So I'm trying to see where something is pointing really far down. At what point does that happen? So I get this, the rotation axis vector should just be in the X. Local vector. Local vector is pointing really far up, right? It's pointing really far up. So that seems fine too. It has the smallest change from the x-axis, so this is fine still. Yeah, this still seems fine. So this is pointing in the correct direction. This is pointing where I see it right now. So I suppose at this point it's wrong. Okay, the bone rotation is a quaternion. I need to look at it. Yeah, okay, so relative to the parent, it is rotated 43 degrees, which I think a positive rotation is counterclockwise. So this still makes sense, right? A positive rotation on the x-axis would be orienting it up like this. So this is still right. Okay. Force update transform. I want to make sure that the body... Yep, that's what I saw. Its x-axis is aligned. It's aligned on position. And this is pointing the right way. So the mistake still hasn't happened yet. So the bone rotation, let's look at this. A negative 51. Does that seem right? So this is the bone rotation relative to the parent bone. Which I guess makes sense, because if your bone is oriented like this and the next bone is like this is like, you know, negative 53, 51, so that's a clockwise rotation down. The Y rotation doesn't make sense. I don't think there should be a Y rotation. So I get the bone rest of this. But last rotation should be that bone rest. I mean, it's probably just better to look at the quaternions. I mean, it's really close. It seems... I don't know. It seems right. They're close. So where does the problem happen? So now I've got to update leg. So this is post IK. So post IK has just happened. So I guess the idea is that IK has put this... I mean, it should be in the same spot. I'm looking for... This is the very last leg. So I'm looking for 5. So the leg normal... okay, this is the global direction that the leg is pointing in. This is... yeah, this should be the normal of that last segment on the leg. That's pointing the right way. It's got that, you know, positive X, very high up on the Y, and then a very small negative Z orientation. So I'm just looking at it. I'm just showing this so that we know roughly the angle that I'm looking at it at, right? So this is roughly the angle. So on these coordinates, this leg is pointing up, it's positive X, and then it's very slightly negative on the Z, right? Did I like, I almost lined it up perfect. It's nearly perfect. Yeah. So it's still making sense. It still makes sense. That is where it should be. And then I rendered it out where it was. And then now what I'm going to do is I'm going to teleport the target global position to where the IKS told it to be. Okay, so I think at this point, this is now... Okay, this must be interference from... Okay, well, let me check. So, I think I can just click top level. Copy. Okay. I'm going to go here. I'm just going to put this marker at that location, paste value. Yeah, so this looks correct, right? It's way up in the air. That's where it should be. So this still looks good. I guess now I check to see. Oh, well, yeah, this is post IK. No. No. This is prior to IK. So now, okay, so there still could be a problem. I could be teleporting the target to a crazy location. Don't care about that. So I'm going to go in here, look for index 5. Okay. So anytime I move it, we are stepping. Debug draws. This is all fine. Leg speed. 1.3 meters per second. Leg speed is probably a really bad name. This is more like how fast I can move, how far I can move the target. So I get the step current position. Relative to the body. I'll even just copy this. Or this is actually relative to the leg. So if I... Yeah, this is relative to the leg. So if I go in here, leg targets, back, right leg. If I move the marker in here. Collapse everything because it's just defaults to all that. Yeah, same thing, right? This is where I see the leg. Okay, so the target's in the right position for sure. This is relative to that leg. I do clear the Y position. Step goal, step target. That's where we are, that's where we want to be. It's kind of in the same location a little bit. Just mostly moving it down to the floor. The step vector, new step. So this is the change. Right. Seems fine. So now step height, I wonder if it could be step height is being really bad. So the new step Y. Okay, that's just the same value. That's barely any different. Yeah, that's barely a change. I've moved down a centimeter. Right, so this is where we are. This is what we're targeting. It is going to delta this out again. So that's actually going to be a little bit closer. Yeah, so it's mostly spending a lot of effort moving it down, right? We're not there yet, so we just update the target to the new step position. target last global. Let's check that. This is where I just, this is where I just teleported it to. Right, so, yeah. So this is the change. This is the change of the IK that I've made. I've gone from this marker to this marker, right? This is barely anything at all, right? That's barely anything. So this seems correct. Okay. But yeah, seems right. So I'm going to skip down to the very last joint. So this should be joint 17. So I want to see what the error is reading as. In the error, I expect to see like just a small velocity. I hit step into. It really didn't run that. It's annoying. Okay, well, step into just doesn't work on those. That's terrible. Okay, so now we're in this position. Now you get to go through this whole thing again. I'm just going to hit continue until I get down to where I want to be. Shortcuts. If I just had the Boolean operator, this wouldn't be a problem. If I just had the Boolean operator, I know why the step into didn't work, because it just stops. It actually just stops running. What garbage. What garbage. Okay. So I'm gonna take this off completely, because I now, it seems like, yeah, I mean, it's literally like it applies an impulse because all the other ones don't, and then that impulse just stays there forever. And it never removes it. Okay. So I see, I mean, really like the entire last leg is teleporting like crazy, right? So looking for, in fact, I want to put it up here so that I can like skip around correctly. I'm looking for yeah, the last leg again. So I'm going to start with 16 and 17. Those two have like the craziest. Well, I'll look at 14. Which is this like this like has a very large error. But I mean, at least visually to what I see, but I want to see that the error is like 0. I expect to see like a 0 error on that one. So looking for 14. There's 14. Now I'm going to... Okay, all right. Whoa. The angle, that's not what the angle is it? That's not the right angle. The angle is a relative rotation. The angle is meant to be an absolute rotation, which is from down here. Well, okay, no, I see. So target rotation is just incorrect. It should be the pose rotation relative to its rest pose rotation. Okay. That should be immediately obvious, I think. Target rotation is nothing. The angle should also just be nothing. Great. Okay. So now velocity says don't do anything. Perfect. Okay. I'm just gonna let this run for a second. Okay. It's doing something interesting. It's almost it's looking, I don't know, is this better? Okay, well, it's really slidey right now. The bones still freak out. Okay, and there is a drift. There's a drift happening. Well, I think that's probably just because of that's actually probably just the leg bones. The targets are progressively pulling in on their own, I think, is what's happening there. So that I'm actually not worried about. What I am worried about is that teleportation that is happening and that instability that's happening. Okay, so this one, is joint 14 again. Yeah. So I want to see if it's a problem here. So joint 14 is teleporting like crazy. Every frame it like teleports between like its maximum angles. Put a breakpoint here. Okay, that's not a bad velocity. Yeah, as far as like an angle and radians goes, that's nothing. That's totally fine. Yeah, so this is a negative 0228. Does it change? Okay, negative 5. That doesn't seem right. Well, maybe that is right. It was this value over the delta or this value. So once this one gets small enough, yeah, I mean if it's off by, that's like 2 degrees, I think. Wait, actually that's probably a really small value. It was 02. It's like 218, I think. Okay, so that's like 1 degree. So I'm applying a velocity of 0.5. So 28 degrees per second. Yeah, and it is this times that. That's too high. That's too high. That is too high. Because it's gonna rotate. Oh well, okay, well this is also degrees, hang on. Oh wait, no, that's fine. It's a 1.25 degree difference, and I'm expecting to apply a 0.28 degree difference. So that one's actually fine. That's fine. You know what, my wonder is, does this copy over? Does this save? The turn-ins was so weird. This is negative 0.5, and this is a positive 0.5. Which means that is roughly like a 1.2 degrees, right? Yeah, that's gotta be fine, right? Are the motors even enabled? Yeah, they're on. Okay, so my guess... No, this doesn't make sense. How is it teleporting like that? Okay. This may be... Alright. Let me do this. Let me put a value here that I can modify. I'll make sure it's an export. What is this? This is physical skeleton? Yep. So my idea here is I'm going to make one of these legs, make one of these joints start going crazy. And then I'm going to go on to the remote scene and set this to that index. And then it's going to start tracking that transform and printing them out. So I can see when it comes in, which one it is. This is like an index. I'll call it incoming transform. I'll just print out the transform. I just don't have to actually track it because I'm just printing them every time, so I don't need to remember anything. Just checking the print index. Index is already declared in the scope. Yeah, okay. And then what I do is after I run this, I set its new transform, and I do if I just do this again. And it should be a global transform anyway. I'm just going to make sure these are aligned. Okay. So there's the plan. I'm going to make one of these do something ridiculous and... figure out which one it is. Okay, cool. This is joint 14 again. Okay. Remote. Print index, 14. Now I should be able to... All right. So incoming transform, outgoing transform. So I'm really looking at the... Am I looking at the Y? It's not really pointing up right now. Well, I mean, I guess that means the incoming transform is pointing down. And I'm pointing it down. Step forward. And now the incoming transform is pointing up. So yeah. Alright, so this is definitely physics server interference. What I'm thinking is happening is that it has sort of like a transform correction that it's expecting, and then well, maybe part of it is that it just won't. No, it should be letting it move because these are like that. But yeah, I don't understand because I'm not really even moving it. I'm barely moving it. So what's causing that to happen? Yeah, I don't understand this one. Because it comes in at this location, I'm like, okay, that's nice. And then I leave it at that position. I basically leave it there. So it's not that I'm going in there and I'm teleporting it. The physics server is killing it. Hey, Danilin. Yeah, okay. I'm sorry for your grandma. Helicopter. Ooh, doing a big turn. Big turn. It was practically sideways for a minute there. All right, so I know that part of what it does is the thing kind of builds up an intuition of what it needs to do to fix something. And then on the next frame it comes through and it applies that fix again just as a starting point. And then it tunes it. So I'm giving it comes in with a certain value. I give it a value very close to what it gave me. And then at some point it comes back around and it's just totally in the wrong place. So I'm going to hesitate to just look at the source code because I know that's what it does. Something here must be unstable, right? Like, also this is like the IK is in this, the IK looks this way, but the IK hasn't even processed yet. The IK is still in like the last frame So if I were to tick forward and the IK is down here, then that means the IK received this position and said, all right, let's stay there. But then this leg is going to be way up here because the physics server, somewhere after I've modified it, is flipping it out. So what could that be? I could print the velocities. I'll add that. Though I don't have an index here. Though I guess I can get the index, so... I'm not using Y ever, so I'm not even gonna bother putting that in there. I won't even put it here either, because I'm sure I'm not even gonna be looking at a joint that's doing Z rotation. So I'm checking that the velocities are good. So this is what the current velocity is set to, and the outgoing velocity. The idea is that those are also pretty similar. It gives me like 0.01, and I give it out like 0.011 or something like that. Ideally, it's never going like 5, -5, 5, -5, that kind of thing. Then that would be really bad. Then the instability would be here. So I'm just going to run it again, and I'm going to try to make one of these unstable. Seems like standing in the way kind of does it. Okay. One is happening. That would be 16. Joint 16. Yeah, joint 16. Yeah. There it is. All right. That's an instability that I have. I am flipping back and forth. Okay. So incoming transform, outgoing transform, nearly on top of each other, and then I'm putting out the wrong velocity every time. Okay. Well, now I know. So... then how am I calculating this wrong? Target rotation is the current bone pose rotation. Okay. That might be the mistake. So the velocity is too high. Wait, the velocity is definitely too high. Is it? Because I'm working with... So 0.5 is in radians. Okay. Let me just step through here then. It's good that it's on my side. Glad I hesitated to go look at the source code. So this is joint 14, right? Yep. Joint 16 actually. Joint 16. So current target rotation is this value. And then I get that relative to its rest. So, okay. Sure. So I'm assuming its current angle is like positive 0.5. No, these are... So velocities are just the pure angle changes. Okay, so yeah. Definitely in this case, this is a situation where the velocity is negative 0.03, or the difference is negative 0.03. So whatever I put out when multiplied by, or divided by 100, needs to be less than this value. So I'm going to copy. That doesn't work. So I'm just going to type in negative 0.0305, or yeah, I'm going to say negative 03055. Okay. So there's the error angle. Target is 0.5. The current angle is... So I'm just going to check those. Okay, yeah. So... So is the problem actually that this negative sign is wrong? Well, maybe this isn't wrong, actually. This would be because the IK wants to bring the leg out, so that's what it's doing. And that's the right velocity. And then suddenly the leg is in a different position and it says, okay, well, now I actually want to bring it down. And that's the right velocity. But I definitely had the wrong target angle for target rotation for a while. Let me drop the negative sign at the front and see if that's helpful. It looks like it's wrong because these all want to lift up and it's not going up. So I was correct in that this is meant to be a negative. Yeah, because it's like doing steps correctly, right? It's doing the steps right. So that seems good. So this isn't, that instability isn't my fault in this case, where the motor says 0.5 and I say no, negative 0.5 and I keep flipping back and forth. That's not really an issue. It could be an issue if the torque is so high that it's able to apply that full rotation in a single step, but it's not doing that. Yeah, it wouldn't be doing that because doing that negative positive thing should be like slowly inching it towards 0. So it's doing nothing. And then it would just be like slightly above, then back to 0, then slightly below, then back to 0, that kind of thing. So that doesn't seem like that's not my problem yet. Or rather, this is because it's already been a problem. So I'm definitely putting the right velocities out. And it is true that the incoming transform and the outgoing transform are just totally wrong. Do I modify the transforms anywhere else? I don't think that's not me. Or yeah. That was just a load. That's nothing. This is also part of the load. That's not even a right. Should have saved the story until Olmec is eating. No. That's a read. That's a read. Yeah, so that's actually the only time that I move it. Okay. So here's what I want to do. My experiment now is I want to, well, actually no. It's still not my fault because it's coming in with some transform and I'm putting out a slightly different transform. So it's actually still not. It's gotta be, I must be doing it somewhere. Because I take a transform, it comes in, I give it a slightly different transform, physics server runs, and then suddenly it's in a very different location. I move it a little bit from there, and then suddenly it's in a very different location again. Okay, here's my idea. Um, hang on. No. I was thinking it's possible that this is listening to a transform change and then reapplying the joint. Hey, 47 bot. How's it going? Still working on this better? Yep. I will be for a long time. Maybe not a long time. I have been for a long time. Could still be a long time. Like, the only thing I can think of now is that I want to go into the physics server and, like, have it print out these transforms. But I don't know how to do that for a body in particular. Or rather, a joint in particular. Could I could possibly drop this number by a lot and see if... Or you know what? Let me bring this back down to, like, let me make it 2. Let me make that 2. And see if the errors kind of go away. Or the instability kind of goes away. Is that teleporting? There is some teleport happening there. It's not bad though. Gotta stop rotating. I feel like I'm seeing flashing. I definitely am seeing flashing. Oh, okay. So that still happened. So I guess my expectation is that that would have been difficult to make happen if it was because of this. Because the physics server is messing with it. Is it building up any velocity? I can just read it. It should be the same. I don't know, any kind of velocity. Okay. That's joint 17. I mean, this isn't a crazy velocity. I mean, the whole thing is moving right now, 1.5 meters per second. That's nothing, I think, ridiculous. There is a lot of fluctuation happening. It does seem like it's accelerating really fast. But I mean, the whole body is accelerating. So that velocity didn't look weird. Talking about AI in these parts. Break. Oh. Is that a break? No, I mean, it sort of is. But I'm also standing inside of it. Alright, I feel kind of convinced that it is probably the physics server breaking. But I thought it should have... If I drop the physics steps down to like 2, it should like do nothing. Also, I'm struggling to break it right now. I've like twisted all this light. Oh, there we go. $14. Angular velocity looks fine too. I'm not seeing sign flips. Sign flips would mean like really bad instability, but velocity's fine. Angular fine. It's just that the transform, this y coordinate, is literally inverting every time. Actually, it would be the x, or like the z is probably inverting right now. Yeah, the z on the x, the z on the y is inverting. So it's going from 0.8 to 1.3, 8.4 to 1.3. So that's really bad. That's like basically a whole axis change. So that's what it's reading right there. But the value that comes in, I don't send out a value that's too different. But then it comes back really different. And this is the only place that I change it. Though I kind of wish maybe there is a way to look at that. Is there a signal that I can look at and just say like, hey, every time your transform changes, tell me? No. There is like notification. There actually is. There is. Okay. So here's what's going to get annoying. I'm going to try to make a specific one of these break. It seems like the back legs have been always the ones to break, so I'm going to go to, yeah, back left. This one, I'm going to put a script on here. Yeah. I'm going to do notification. Transform. Local transform changed happens every time it changes at all. Hey, some Ada Fox in the background. Her new videos are so good. Who is that? And I'm probably not. Local transform changed. Node 3D calls this whenever set quaternion. Yeah, literally anytime something happens, this calls. Anytime something happens. So I'm going to put a script on here for that. And I'm going to track it. So I'm going to say and I think what I probably want to do is just look, I might just do like a manual breakpoint so it'll just happen as soon as it really starts to kick off. Or maybe it'll never happen. So just save it and then turn. And then otherwise, I'm going to compare the Y axis on these. Is that right? I'll be comparing the Y axis. Yeah, the Y. So if a last y dot new y what is it? It's math a cosine or math cosine of 10 degrees. Whoa, okay. So what is this, 0? Yeah, okay. If it is less than 0.4. Breakpoint. So this is just going to tell me, is it happening because of me? What did I attach the script to? It's not there. It's not there. BL Tarsus body. Where's the script? What? All right, that was weird. I don't want to make one. I want to load one. Okay. All right. So I'm going to try to make the back left, this one, break. Okay. That's not more than 10 degrees. But it is teleporting around really bad. Okay. So this is definitely more than 10 degrees happening. But it's not tripping over here. So I didn't even start yet. Okay. What? That's not correct. That's not correct. What is happening? Okay, weird. Continue. That's not real. 44. 2016. On mouse entered? What is happening? Okay, breakpoint there. Breakpoint there. This isn't happening at all for me. It's not even running. How do I turn this on? Set notify local transform. Okay, cool. I don't care right now. All right. All right, break the leg. Break it a lot. More than that. Oh. Okay, so the question is, when is this happening? That's the question. When is this happening? I don't know. So I'm just going to hit step over, and then it should come back somewhere. Integrate forces on the launcher. Okay. So what I'm thinking then is that it wasn't me. It's not me. This is just literally happening. I wish I could know more about the stack frames. Can I... Okay. I don't know if I really can. I want to... Okay, that's it. Godot. I don't know if this is a thing. I think the best I can do is do like push error, and it might give me something. Is it literally just called print stack trace? Engine capture script back. Yeah, I don't want that. I want like the full. I wish someone was more descriptive of like what this means, because my issue is that I only get the script, which in this case is one line. I want like to know where it is in the engine code. I want to know if this is specifically coming from like the initial transform assignments right after the physics server ticks. And if so, then I know it's a physics problem. Native backtrace. This isn't what I'm... That's not what this is. It's not what I'm... $700 line. Also, this is 4 years old. Okay, I'm gonna stop this because I'm at a dead end right now. GitHub pretending to load. OS singleton print stack trace skip called. Ah, awesome. That's exactly what I want to see. Backtrace. This is like totally inside of completely in the engine. So some crazy stuff. Okay. There's probably no way that this works, and this is also so old. Why is it not merged yet? What's the problem? Is it still being worked on? 2 months ago. Dude, I would be so mad that this isn't merged yet after 4 years. Okay, well, I want to try it. Let me just see where this is put in there. Because I need like the language thing. And I just see this as like a language. Oh. Because it sounds like it's just... What? Damn. How? So it's not even usable. Four years of procrastination. Okay, so he just wasn't even... Okay, I'm just gonna leave a comment and say I would love to have this. I'm just gonna be very descriptive about like why I would love for this to be exposed. Because I really, really want it right now. Okay. Yeah, like it's here, but I can't really even use it still because it's purely engine only right now. And it's just like to print the backtrace of a crash. So whoa. The good thing is he's not even called either, so I'm not really sure, like... Like, who's meant to be using this? Like, there's not even... I was like, oh, it's in the crash handler, but then the crash handler doesn't actually do it. It never calls print stack trace. It's just running some normal stuff, and then... Yeah, I don't really know what it's doing. Alright, so... I mean, it already means a lot that the very next thing that happens is the launcher integrate forces. That means this is happening from engine code. I mean, I think this must be happening from engine code, right? I'm not clicking continue and then it's going back to some code I wrote. It's going back to like the first line of an integrate call. Integrate forces call. So I mean, that narrows it down to call queries. It narrows it down to this position. So it's here. This is flush queries. This is where integrate forces is called from ultimately. Which means there's no user code prior to this. My user code stops here. So it's definitely something in the physics that's a problem. And I don't understand. I get the idea. If the physics is keeping track of how much change it applied from the last frame and then reapplying it this frame. But it's still fractional. It's like it does a step and it says, okay, well, this is where I am. Let's do 18% of that. All right, let's do 18% again. Like, I think I have it on... I mean, I feel like it might have been happening less when I had it at fewer position steps. And I was thinking I could apply my own stabilization factor, which maybe I should. Maybe I should apply a stabilization factor. I could do that. Because now that I think about it, it is the case where sometimes it's trying to teleport it several centimeters. So yeah, basically anything more than a centimeter is not good, because a centimeter in 100th of a second is... I mean, it's like times 100, right? I mean, I guess that's not a big deal, right? That's a meter per second translation. But yeah, maybe I should use that. So I can compute a delta here, and then use an interpolation to get there. So I'll do that. I could even just do global transform interpolate with, and then a weight, and my weight would just be, this is just such a, I straight up did not do that. I mean, it would just be like, it would just be this simple. So I'm not snapping it all the way. I'm just snapping it 20% of the way. In fact, you know what? Since I know that it's doing like one step at a time, I'll even bring it up to half. I'll bring it halfway. I don't really have to do that. I can probably get away with 2, and that'll probably be fine. I think that's all I would need. This is setting the whole transform, so okay. It's already wobbly though. It's already wobbly. And that's what I don't want to happen. I don't want the wobble. So it needs to be higher than that. Let's go to 0.4. Maybe it is me. Maybe it is me. It is that I'm using too much. Yeah. Okay. It seems like it's just like there's an interference happening. So if there's an interference happening, what if I didn't do any of this then? Since I'm the one taking care of it. I am taking care of the linear limits. So you don't do any linear limitation. You don't do any angular limitation. I take care of it. You just do the motor. I will leave on this the angle limit. So this one's marked off, but it's going to turn it on and it's going to set it to a value. I'll leave that one on because I don't touch that side. I only touch the other ones. So I'm just going to turn off all of this. So these won't be doing anything anymore. And it's all on me to do it. So it should be, so this is probably going to fall apart, honestly. Yeah, okay. So something ridiculous is happening now. Yeah, so the bodies like really fall apart. It also seems like I'm trying to teleport them and they don't care. Which is really odd. So I'm just gonna type in a 1 here and see if they hold together. Okay, so they hold together, and then they detach abruptly, and then they never. It should be just like there, right? This should just be over there at this point. So this is joint 14. So let's go turn that one on, or turn on the printing. So incoming transform. So yeah, I'm moving it like 10 centimeters and then there. And then it comes back in the same position as before. Like I didn't do anything. Yeah, weird. It just comes back like it's in the same position as before. Velocity? Okay. Well... yeah, okay. Velocity makes sense. It is sort of like it's continuously falling and I'm not transferring velocities. Okay. All right. Damn. Okay, so part of it is that I need this to do velocity transforms for me and position transforms, but it needs to, like, it needs to forget. It needs to forget. So I turn all these back on. I could, okay, hang on. I could leave that on and just not do the angles and handle the angles myself. That's a possibility. I can handle the angles and leave it like that. So the linear will fix its velocity. Linear will fix its velocity. And its position. So I don't have to do position. I just have to fix angles. Because that's, I mean, ultimately that is the only thing that I think this is not doing a good enough job with, is the angle fix. Alright, so I'll do that. So I will no longer be doing this. I will be doing basis. In fact, I don't have to do global basis. I can just do basis. So basis will be equal to stop doing that. S lerp to this with, I'm just going to start with like 0.5. So it'll be very high. Alright. Well, that's instantly terrible. Alright, I'll just do global basis then. I'm not sure if that even matters. I feel like it shouldn't. It's still awful. So if I did very small rotation correction, I mean, it just falls apart. This is so sad. That's actually just so sad. What if I don't do anything? I don't do anything. What happens? There is like sudden snapping from... Also, the IK is just like insanely out of place. Like, this is really ridiculous. How is this the result of IK? Like, that doesn't make any sense to me. You know what? Here's an idea. What if I actually let them rotate on the y-axis? And I let them be free that way. I'm trying everything. You actually limit on the x. Okay, so it still breaks. So what if I took... So then what if I came in and I fixed the Y rotation? I fully hard fixed the Y rotation. So it's not going to limit on the Y. It's going to be responsible for the other axis. And... Actually, why did that not work? Did I mistype this? Did I type this wrong? How did that not work? Because doing the whole global transform is like pretty stable. But if I do like any amount of extra correction for the rotation, it totally flips out. Okay, so let's just say that I do allow those to rotate and I'm going to do like a very large correction. A very small correction. Just a little bit. And it's like instantly unstable. Can I make it so this is... So I just do a full Y correction? Is that a possibility? 100% a Y correction. But what that means is I take... To fix the Y, I take the opposite axis. I set it... I slide that out. I mean, the thing is, that's what this is doing. This is doing like a full 100% correction. And then this happens. And the joints are like totally crazy out of place, and like how are you so far out of place? Do I have my position steps still really low or something? Nope, those are normal. So, like, correcting 18% of the error, which, by the way, 18% of the error would be... You're within... If you're a meter away, you're within 4% of that distance. So if you're off by 10 centimeters, you're going to be off by less than a centimeter in a single step. Like, that's... But it obviously isn't. Like, I just watched it stay like 20 centimeters away several frames in a row, and it just did not get closer. I mean, it just feels like I can't do anything. Nothing is making this work. I can't even do like a little bit extra. That's still, I mean, look at this, right? It's still just super unstable and does that. And if I don't do anything, then it's just gonna be normal. I mean, kind of. I don't know, not really. Like, it doesn't look the same. Maybe my number is too high, right? Maybe the number is too high. Wrong. Yeah, it's like 0.8. Is that my problem? Okay, let me see. If I were to let me drop something. Let me turn the motors off. So this should effectively deactivate the motors. Not that. From my side, so they shouldn't be trying to do anything. Okay. Alright. Why do I want to be so far forward? Okay, you don't. It was just weird. Okay. Okay. So this is the femur, and it's got the... Huh? Oh yeah, no, that's right. You know what? No torque limit. Instantaneously reach your target velocity. Okay. So this is with supposedly, you know, really high precision here. Right. The best a computer can offer. Okay. So my thought here is that when I'm doing this setup, I'm not going to turn these on. I'm just going to leave them off. So that I still have to manually turn them on. And what I'm then going to do is... So I want these to be on. I'm going to lock... I'm going to turn this motor off. And I'm going to lock this. And I'm going to let that be free, I guess. No, I'll actually leave it locked. So this joint should be locked, fully locked. Okay. I need to turn the motors off. That motor's off. Yeah, I'll just turn the motors off so that we're just kind of locked in place. Okay. So technically that's not... Right? Did I mess that up? Oh, it's copying in the limits. So just going to pass on this one. Let the other ones go, but this one I want to be super rigid. Okay. I don't know exactly what I'm looking for here. I really don't. What if... I'm thinking like, what if I didn't use motors at all? And instead, I only used limits. And every frame, I'm just copying the angle limits back to the bones. Or I'm copying the angle limits to this. And that's how I move it. That still doesn't work because this whole thing can still rotate anyway. Okay, let me think about what's causing the rotation to happen. The rotation is really happening because this joint right here, I guess, is just like far away from this amount of, from the mass that's on this side. So a small amount of torque over here is going to like cause a very small angle change, but it's going to be like very obvious at this point. So what if instead, I kind of lock, I do something really, really weird, I think. This would mean that I can go in there, I would have to go into the code and maybe set it up so that I can change the relative transforms of a joint on the fly. And what I would do then is essentially I'm creating a direct connection from this part of the leg straight to the body. But the joint is like, you know, it's got this big offset, right? So the joint parameters would say your position offset is wherever the IK wants you to be. So this is your position offset now. And then it would say, and then it would say your angle offset is whatever, again, the IK should be. And I just rely on, the 6-degree freedom to act like a pure pin joint. I say a pin joint. Just like it's stuck here and it has to have this rotation, and every frame I'm updating that. I'm changing that relative transform. And I'll do that for each one of these bodies. So this leg would have a direct, this would be a joint that essentially passes everything straight to the main body. This would be a joint that passes everything straight to the main body. This one would just stay where it's at. So what this means is when forces are passing, so when I hit this leg, that force passes straight to the main body. And then on the next velocity iteration, these two joints read that velocity change, and they would update as well. They would, you know, refit the position, do whatever. So the leg, I think in that case should be super rigid. I can probably drop the steps down a lot, because now it's technically just one joint, right? I mean, it still might require some velocity and position steps to really be there, but I think just doing that probably just totally solves all the angle problems. Because now it's like, in order to get this one to torque, you would have to literally apply that rotational directly to the body to make that even happen. And doing that would twist the whole thing. I mean, that could... I mean, I guess if I think about like what that would look like, I guess that would like take this body and rotate it that way. So yeah, I mean, that kind of adds up. And then this one would rotate that way, and then this leg would rotate that way. Because yeah, the real issue is that this joint is effectively responsible for a lot more mass than it actually can see. Which means I have to crank up. I would have to keep cranking things up. Okay. I'm going to go with this idea. So I just need a way, generically, on a joint 3D. It'd have to be a physics server. It has to be a direct physics server access to be able to change these. The only issue I can see is, again, I'm probably going to have to manage that delta stuff where at the start of like at the setup position constraint, setup velocity constraint, it copies in the last value it had. And if I have changed its offset, its relative position, frame to frame, then I mean, I would say it's possible that could build up and get really bad, but it shouldn't. And then my hands are totally off the physics server. I'm just saying, hey, I want you to put it here now. And it can still handle position, velocity, stuff like that, all on its own. Yeah, I guess it is just the question of like, is that really safe? It's probably not so safe in the sense that those like stored velocities probably need to be cleared so it can just recalculate them from scratch every time. So maybe that's part of it. What is this? Update translation limits, update rotation limits. What do those methods do? That's just like a correction. Rotation limits. Sort of the same thing. Pass limits onto constraint part. Set limits. Swing, twist, constraint part. Set limits. Now I'm looking for the swing, twist, constraint part. There we go. Yeah, that's nothing. Yeah. I mean, it may be fine. Because I'm pretty sure the in warm start impulse ratio can find it. It's in somewhere around here. I think it's physics space. Jolt space. Huh? How do I determine the... It's somewhere where it's like, it's either 0 or it's some fractional value. I can't remember where it is. Okay. M constraint warm start and previous step delta time is greater than 0. I would do that. Otherwise, it's false. M constraint warm start is default to true, and it seems like it's never changed. So it's always true. M previous delta time is greater than 0. Do step delta time over the M previous. Okay, so yeah, it's always, all right. Okay. All right. So I just need to verify that, and that just means it's a 1, basically. Because this is the incoming value in delta time over collision steps, which is actually a 4. Oh, it's 1. Even though it's supposed to be 4. This is what it was, what I remember seeing. This one isn't even used, is it? Yeah, I don't know what that is. Okay, whatever. So yeah, it's that over 1, so it's just delta time, step delta time. It's just the same value every time. So it's always coming out as 1. The warm start impulse ratio. And then what warm start does exactly is it calls these warm start, which these are angle constraint parts. Angle constraint parts, I think, just reapply their lambda values. Yeah, it takes the current value and applies it. So this is what I'm concerned about. Is this changing the limits there? Means that it starts from that and then it has to slide back. Wait. Am I like... Hang on. Yeah, because I'll be teleporting them, right? I'll be saying, hey, I want you to stay here now. Because those parts can physically move. So when I do IK, I see where they are. I see where those positions are now relative to the main body. I calculate that offset, and then I reapply it to the server. So the offset's going to be different. So basically it'll be like, hey, after this step, I'm actually kind of far away. And I got sort of back, and here's my impulse ratio, or here's my impulse. So I was doing an acceleration of like 10 meters per second to get back, or to match with the main body, or whatever. And then I slide it to a new position, and I guess my thought is that could just be unstable. I would have to be sliding it to new positions and changing those joints. But I guess the positive to this is that I don't have to worry about motors. I don't have to worry about copying angle constraints. The only thing I'm doing is computing where the body should be and having it be a direct joint connection to the main body and changing that offset relative to where IK wants it to go. And then for the IK, I think I need to do initial preparation for the IK. So I need to copy the rotations of the bones, but not their positions. Am I copying their positions? Oh, well, what I need to do for the IK is fix the rotation, copy that into the bone, so that the IK is not working with some weird Y rotation or anything like that. So the IK is still working off of roughly like where the leg is right now. And it should have a clean input. And then the bodies are just trying to very, very rigidly stay in that position as best they can. And since they have that direct connection, it's as if they're attached to a rigid wall. So forces will pass the body. I guess that's the one weird thing, is the forces might pass the body in a very strange way. And it might look weird. I mean, I guess I have to test it, but that requires, yeah, it still requires me to All right, how about this? How about this? I can do sort of an initial test where they're not chained together, they're still connected to the main body. Because all I really have to do is clear the node parent. I can just take the node parent off and then put it back on, and that rebuilds the joint. That deletes the joint from the server and reconstructs the joint. I could try that. So what does that mean exactly? What would that mean down here? I don't need any of this open. What does that mean I do here? I have to, well, I guess the real thing is up here. It's what I do up here. So instead of moving the body, I take that joint, I teleport it to where it should be on the parent. I would... No. I don't do... Okay. If I can just directly change the relative offsets, that would be great. I'm just thinking if... Can I do the test here without doing any of that? What would the result of that be? The result of that would be teleporting the whole body to where it should be. Clearing the node A, resetting node A, teleporting the body back to where it was. That would work. That's how I could test this now. Okay. Let's get it set up then. I'll bring it back to this, and I think I probably want to leave this as that value because that's what it should be. Right. Okay. I'm just going to close test 4. I don't need to have that open. So yeah, I leave all the angle limits on. I leave all that on. I'm not going to do motors. I'm just going to test pushing into it. I should just be able to change this and it not matter. You attach there now. I have to do this for all of them. Have I expanded them all? I mean, I guess I'll know if one of them was wrong. I may not totally like it, but I think this is probably going to be the only, like literally the only solution that I have left at this point. Make it a totally rigid joint and just do offset stuff. Trick it, basically, into look, not tricking the game into doing this, but tricking the player into thinking these bones are strung together in a line. Right? That's the trick. If it looks like they are, that's what matters. They don't really have to be. They just need to look like it and respond like it. Okay, so they're connected the right way. I'm not doing anything. I don't have any motors turned on, so I just want to see what this looks like now. It looks super rigid. Well, you know, yeah. That's to be expected. Yep. Okay. Also, these need to be... I need to get rid of this comment that I put somewhere down here. So bring this back so these can spin. So yeah, right now they're going to look weird, right? Because these joints can still move individually. They're not like totally connected yet. I'm trying to push any of these off. Okay, it's really just not... Oh, there we go, right? So far this looks... It's looking really rigid. It's looking really rigid. But obviously the joints are just totally wrong. So. That was first step. That looks really rigid. That looks great. How low can I go? Can I go back to like 8? Could I drop this to 8? That would be cool. Also, wait, wasn't this actually at 20% for 2? Have I been at a really high? I mean, technically, yeah. Yeah, okay. It's looking like something. So here's maybe the thing that gets me. When this joint angle changes, I guess what that means is I would like, this would rotate out, and it would just rotate out like that. Right. Oh, these need to have exclusions with each other. So if they intersect the main body, they need to exclude the main body. If they don't intersect the main body, they don't. So I actually need to turn... I'm going to use the fact that this is a tool script, and it should run when I click. So it'll do setup bodies. And then it actually gives up instantly, so never mind. Okay, I can't use it. So here's what I'm gonna do. I'm gonna make it so that these, I turn that off. Turn this off on everything. And I'm gonna fully manage that on my side. Also, I have to add it both ways, I think. That's something I kind of forgot to do. That might be why stuff is moving oddly sometimes. Well, no, that was like from an old thing. This is different now. But I think I only have to add the exclusion in one place, but that's also not how it works. It can pick either body to be the main body and then check. And it might only check one of them to see if they exclude, and not the other way around. Though it probably should. Well, maybe not. I guess the idea with that is you might say have a large object that should not be moved by something smaller, but then the smaller object can be moved by the larger one. I guess that's an idea. Okay, so when I set these up, when I'm doing... Yeah, so when I'm setting these up, if the parent is the main body, I am now ignoring this, so this is just different. So I check to see if it intersects okay, let me think about this. Is this really my last? Okay, here's one thing. What if I have been using just a really way too high stabilization factor for position this whole time, and that's kind of all it's been? You know, I think not, because it literally just like stands there and then slumps and falls over. So I think not. I think definitely not. Yeah, I think definitely not. Yeah, all right. I save the center mass. And then what I mean to do here is I mean to check... Well, I think what I mean to do is I mean to definitely exclude its parent. Sort of do it this way. Exclude contact with its next higher parent. If it doesn't exist, it's just the main body. Exclude the main body from contact with it. If it didn't have a physical parent bone. And on the outside, I think I can probably just drop this, because I'm not gonna have that. I'm not gonna have that anymore. I mean, this one, I guess I can leave this one. I'll leave this one, and I'll do... So they'll exclude each other. if this happens. But then, in addition to that test, exclude collision from so what I'm looking to do here is I get the next higher joint, I guess. So if this is IK, so if joint data is IK joint, and it can't be the first one. So then I grab the bone name, so parent bone ID. Iterate IK. Get joint bone. IK setting. IK joint. -1. Hey Dino. How's it going? It's going well. I am on my, I think probably the last thing I can try for the physical bones. I'm basically trying it so that I just have like a fake joint, really. So these two leg pieces aren't actually connected to each other. I could demonstrate that if I like hit the top of this one. Yep, see? They just attach, right? And the idea with this is that it prevents, I can use a less physics steps, so that when I push on this, the main body pushes, right? So this is the main thing that I need to happen. If I hit a joint, I need the main body to move. I need everything to move together. So the idea is I'm going to use a fake joint now, instead of actually connecting the joints together, because it would just slump and fall over, and it would not work. It could not stand up. Doesn't Godot have built-in joints? Yeah, that's what I'm using. That's what I'm using. But what I mean is, instead of having a joint that connects this piece to this piece is connected to the main body. This piece is connected to the main body, right? And then the main thing is it stops the legs from slumping over. The legs aren't falling over now. They're like, I mean, they're totally not connected, but that'll be fixed later. Yeah, that's just what I'm doing now. I'm trying to make that work. And if that doesn't work, I need to find something else. Like, this should work. It is gonna look bad. It's gonna look worse, but at least it's gonna be better than not having it. Or, I don't know, maybe there's some secret thing that I haven't thought of yet. I think it's hopefully it works. Yeah. I mean, yeah, like what I said, like when I just have them connected together, I would have to go to this and set this to like 100. And even 100's not enough. Like these both being 100 still wasn't enough. It would still fall over and look really weird sometimes. Like the legs, the whole leg would just like crush, I guess. It would just bend out of place. And there's nothing I could do to stop that from happening. So now none of the joints are connected to leg pieces. They're all directly attached to the body. So they shouldn't be twisting or doing anything weird anymore. It was more the fact that these two bodies here, I could push them a little bit, and that would cause this piece to spin out of place. And it would not be able to apply enough correction to get that to stop happening, so the whole leg would just tip over. So get the parent bone ID. Please. I hate my naming choice. I'll call it target. If we found the attachment, things have already moved. That's actually the problem. Things have already moved. So I actually can't do that here. I have to. I can do it up here. Where could I do it? I'll do it here, because at this point I'm pretty sure it's good. If that's the same... Alright. I feel like I've done this many times where what I'm really looking for is just... So awful. They haven't been... I can just leave that like that. And I do... grab that, and then I add the exclusion. Finally. Joint data, body, add collision exception with that, body, add collision exception. Okay, so now, all right, nice. Yep, cool. It looks even worse, but that's better. I swear that's better. Okay, that was needed. The Freakwave Marathon will not have PV, not even season 2. What? All right. there's that. That's it. Now the next thing is I think it's kind of all it was. So the next thing I think is I want to be sure that I want to be sure the skeleton is getting perfect results. So that means okay. I'm just annoyed. It's like a lot of tedious stuff that I gotta do. It's a lot of restructuring. I think I'm gonna commit what I have right now, because this has probably been a lot of changes all at once. This Tarsus script is just gonna go away. I don't need you now. That's no. This one, detach. There we go. And then delete it. Okay. What am I doing now? What am I doing now? Right. I was gonna commit stuff. I am gonna drop the print index thing. Is that not here? It is here. Where is it? Oh, it's much higher up. Okay. I don't think I need to worry about that anymore. This is the last try. There's no debugging transforms at this point like that. Say the delta, do this, all of this, all of this. Skip the last one. Copy things in. Yeah, okay. The total mass is good. That's good. That's all good. Yeah, technically I do have to worry about that, because if I'm applying anti-gravity, I do have to now care about the legs, so that still works. I guess I'll go ahead and fix these joints. These joints are all, or the boxes on these ones are all wrong right now. Though I don't know, maybe it looks cool. I'll leave it for now. I thought it might have looked cool, so I left it. That's what I did. Why is print index still set to -1 there? Can we stop doing that? Probably like I don't send. Cool. Why did the ID change? Actually, why did the ID change? That's just dumb. ML target 2. Okay, I can definitely commit, I think, the first ones. Hey eCave. You hear what programming language is this? This is GDScript. It's basically Python. Though Godot wants to be really adamant that it's not Python. It's Python. It's like 99% Python. That, and then I think all the code is fine. And then I'm not adding roller leg. Okay. So yeah, one of those did get deleted. And then those resized and these all moved. And then the bone names and IDs changed. That's fine. Why is there a mask? Oh, mass, not mask. That's fine. I turned off all of the unique things. And then I added that. So there'll be no more motors. And they all attach to the main body. Yeah, that should all just be good. I won't send that one. I won't send the project. Oh, I do need to add that. I did change this. Not sending that. Why are those there? Have I modified these by accident? Yeah, I mean, just turn that off. Okay. Bunch of markers. I'll just delete them. Oh, and then the Blender file too. All right, I don't need to send the test scene. That's nothing. That I do need to add. Okay. I work on... I'm like drifting further and further over. Work on... other legs. Whip. Yeah. There's still some other stuff, so roller character can set a total mass and it's more like a body leg mass ratio. Is this Hollow Knight music? Probably. Yes, it is. Don't know what you're doing yet, but grateful for not using AI CLIs. Yeah, I don't want to use those. I'm trying to I'll show you what I've got. So ignore the blue stuff. The blue, don't worry about that. So basically, I want it to be that when I push on the leg of this guy, the whole body turns. And I've got that. However, you'll notice the joints just seem like they're floating here. That's because they are. Basically, if I set the joints up so that they actually connect like this leg segment to this leg segment, I need to crank up the physics server to like 100 times the number of steps and iterations to make it even stay still. And that's still not even enough to start moving the legs with motors. It pretty much breaks as soon as you start pushing on it. So now the idea is I use a joint that is just floating here in the air that connects this leg segment directly to the main body. Same thing with this. This one is connected directly to the main body. So the segments are not connected to each other. That'll be the next step, is to make it look like they're connected to each other. That's what I'm in the process of doing. For now, it means that the legs should not slump over and fall over anymore. I can use really low normal physics server iterations. And I still get the result where pushing on a leg pushes on the body. That is the real thing that I need. I need to have that. Also, if I do this, I could go to springs instead of rigid connections, which is what I would like to have, because I need to be able to break the legs off. So if it uses a spring, then that means it's allowed to be some distance away from where it should be. I can read that distance, and if it exceeds some value, then I say the joint's broken, and I can delete the joint, and then the leg piece flies off. It's all done with code. there's a lot of code, but the actual joints, there's code to like set the joints up. I say set them up. They're already set up, but then I have to do some, I have to do a lot of bookkeeping, I guess, so that I will be able to update them later. So once I get the legs, to make the legs move, I need to know stuff about the joints, I guess. And also, rigid bodies contained within rigid bodies don't work, so part of the code is just to take the bodies and pull them out to the world. What else does this have? There's kind of just that on the crawler character. I just wanted to commit that because I want to get food. And also there's a lot of code, and I don't want to lose it. So I just want to check to see if I know exactly what I'll be doing. Right. So I need to get this to be the transform of the joint that it actually cares about. Probably what I'm looking for really is just, yeah, if I know that I need it to be clean, I can just provide it the rotation. I don't provide the position. So I'll just start with that, and it should make the IK not look broken anymore. Maybe. Okay, IK doesn't look broken now. I guess it's just caused because these, yeah, alright. Yeah, whatever. I don't know why I was never good at drawing, so I use IA to build the front end. I don't know what that is. I don't know what IA means. Did you mean AI? So the IK doesn't look broken. The IK is getting good rotations. Yeah, and then, okay. And then the plan would be I wouldn't be doing motors. Though I guess I could just turn on the motors and see. I don't know. I'm gonna get food. I'm just really hungry. I'll be right back. I meant AI. I mean, like, I have... What I'm trying to say. I don't do front end, but I've never felt like I was incapable of it. So I would say, like, I don't really know if you... I think for the simplicity of what UI is, you don't need to be good at it. If you can get it on screen and make it not look terrible, which you would know when something looks terrible. You're like, oh, that margin's way too big, or something like that. You'll know. So... yeah, I feel like I've made good-looking websites knowing nothing about, or not really doing any studying, I guess. I just, like, try. I had a previous project, which I will eventually get back to, but I can't do it right now because it requires a skill set that I just don't have. Where I was making a whole thing here in the editor. I'm just showing an example. So Godot, you can set up your own custom views. I would say Guide is pretty good just because there's a lot of stuff that they have to get on there, but also I think it looks kind of, it could look better. And I was just setting up like or what I was trying to do is I was trying to set up a system where I can edit an AI behavior tree in Godot. I never really got far enough to do anything, but it like I was working towards it. And I think you just everyone has a good eye for it. If you're looking at an example like what I'm looking at here, and then I would flip over to mine and I would say, all right, that looks weird. But like that doesn't match anymore. That kind of stuff. Can I fly come with a good design? I don't know why. I mean, you just don't, I don't think you need to think of it that way. You just need to say, what do I need? All right, here's the box. And you go from there. All right, I'm going to get food. I'll be back. I'm back.
All right, I've got food. I'm going to eat.
I'll be back.
What are you eating? I had a chicken sandwich with Swiss and guacamole and onion.
That's what I had. Yep. Pretty good. Though maybe I needed more guacamole. Because even though I feel like I put a lot on, I didn't really taste it. All right. I'll be back. I'm back.
Make more.
Yeah, I'll do it again, and I think I'm gonna double. I need to double what I put on there. Okay, so now IK is good. IK is only getting rotations, and they're getting good rotations. So essentially the idea is this. I only care if the joint has I need something here. I need to the joint ID. Right. I only care about this if the joint if joint data IK so I only care about this. So what I do is I'm going to get the bone position of this parent bone. Or really, actually, no. I'm just getting... Where am I teleporting to? I'm teleporting it to the joint position, not here. Not here. Not there. It's down here. So I get this whole setup. I'm just gonna can I do like return right here? And it not complain about the next line? Awesome. Okay. So instead what I'm gonna do is I'm gonna go through I don't care about these if they're not an IK joint or they're not, or they are the first joint. If they're the first one, in fact, I don't really need to do the double check, but whatever. I'm going to say less than one. I'll skip the double joint. If the joint IK ID is 0, is not at least 1, don't care about it. When it is, I have to teleport it to its... I have to do the position fixes. So this is just... Ideally, what I'll do is I won't reconstruct the whole joint every time. The problem with that, and it may turn out that I can still, that I maybe should do it this way, maybe it won't be that slow. The problem is that it's a memory allocation. It's a memory allocation, it's like a list update, it's a lot of stuff. The other problem, but it may turn out to be a bonus, is that it clears the work. So whenever a position, whenever a joint runs its stuff, it stores up, it builds up a lambda change, right? And then that change is just reapplied on the next frame. So warm start is at the start of the frame, and then you solve velocity constraint 10 times or whatever. So what happens is it's building up whatever its total is, and then it's just doing the changes throughout the step. And then on the next frame, it starts by applying that full change. And then it starts applying changes maybe to undo that. So like the new lambda is less than the value, so it starts rolling it back. That's the idea. So that's one downside to reconstructing the joint. That information is lost. It may turn out to be good because I run this and it's like, it's not laggy yet, but it behaves well. And then I test it, and then I say, all right, this is good, maybe. Honestly, like at this point, this is all that I got left. So then I work it into the physics engine so I can change that. I can directly go in there and change that relative offset, those relative transforms, without doing no memory allocation, no array list updates, none of that. So it'll be much, I say much faster. A little bit faster, you know, just not needlessly slow or slower. I mean, it's really probably not even an optimization that's going to matter, but it may as well be done. It's only a benefit, right? However, here, the test is that I can just do... I can do this. I essentially... I think what I'm doing is I'm taking the... I don't really need global like, because these are bodies, I know that transformish is what I should use. I take their transform, and then I save that. I take where it should be, so it's like the bone transform. So this is going to be the global position of the actual bone. Okay. So the idea is I literally just teleport it to that position. I clear the top node, I reset the top node. That updates the joint constraint. And then I move the body back. I call this, so this synchronizes it to the physics server, which I think is probably necessary. Maybe not. Don't know for sure. So I do that. And then yeah, I do joint data joint. I'm gonna save the node. Node A. I clear it, and then I set it back. So the thing is, both of those are going to cause performance issues doing this, but this is the best I got. This also relies on the joint being the child of the body, which is... Maybe it's not fine in Godot physics, but it's totally fine in jolt physics because those locations are cached instantly on the spot, and that the joint is not really a location in space. It's just a relative position. It's a relative transform on two bodies, and it tries to match those transforms together. So now the joint is set up to have its constraint match the orientation of the leg IK. And then I have to move it back. And then probably do another force update. I probably don't have to do the force update there, but I'm gonna anyway. I probably don't need to. Alright. So that's what happens. That should be the process. I teleport it to where I want it to be, force the joint to rebuild, send it back to where it was. So I've left the state. I've done nothing but like effectively change the location of the joint. Well, they're moving. They are moving. They're very jittery. So, I mean, I don't know. What do I think is happening? I don't know what's happening. I don't think they should be detaching. Right? Because in my mind, what this means is that this joint constraint for here is teleporting to this location. And this is where it should be. But, like, why isn't it going there, then? Let's bring this back up. I guess there's no feedback on... Well, maybe in this case it's because IK is updating too fast. Could it be the IK is making it unstable? Um, let's go to. Is there a way I could do this so only one of the legs is in physics? Could I do that? I mean, I don't know. I guess I just look at any leg. Looking at the front left. This is what I see. So at this point, there's kind of a problem. That joint wants to basically snap down like this. I think that's what's happening. It wants to move down to there. But physics is in the way. Right? What if I had it as like two joints? What if one joint was a rotation joint and the other joint, or I say rotation, they're all in rotation. One joint is I mean, yeah, I could just have like two fixed joints, right? Also, I think the target's wrong. The target should be... The target's in the wrong place. Okay. Let me go back to copying the position. Though bone position is based on this parent transform, which in this case is wrong. Bone position should be just the position of the body. No, it does have to be the parent. Right, because in IK,
Yeah. What am I thinking of? I'm thinking I copy the positions in of the bones. Because maybe that helps the IK to have a better understanding of what's really going on. This line.
Okay. It went bad very fast. It's just, yeah, it's so fast. It's crazy how fast it happens. Are there other kinds of joints? Nothing there. What's the ultimate thing that I want? Now, the ultimate thing that I want is just that the legs can pass on collision forces to the main body and it looks fine. That's the idea. I feel like if I can get that, everything else is much easier. Or the rest of the stuff isn't a problem. Like braking, nothing, none of that. So what can I do? I think maybe what I really want to do is read in. This would be nice. The physics server runs, it does all the, everything moves around, everything pushes around. I step in after it's done. And I say, all right, where are the bodies now? Like imagine that the leg segments are just kind of floating there and they have no attachments. Their bodies are just floating there in space. The physics server stepped everything and moved around. That wouldn't work. It wouldn't work because what if the joint has to push back into another object? Into the object that displaced it, right? That's the problem. What's making it difficult? What's making it difficult is that the legs just fall over. That's the first part. First part, the legs will just fall over because there's not enough position and velocity steps to keep them in place. This concept allows me to transfer any collision directly to the main body, which in turn transfers that directly back to the leg segments individually. So the moment this is reasonable, when does it become not reasonable? It's become not reasonable because things are just glitched and teleporting around. And I think the reason that's happening is because specifically that I'm moving the joints. And that's not... Well, okay. It starts off fine. They start glitching and teleporting around because this middle leg segment drops a little bit. That is kind of... What does that mean? When that happens. What happens to that interior angle? I mean, I guess essentially it's like the interior... Well, that angle doesn't change. Right, that angle doesn't change because it's like I just teleported back to that location. So the problem is that the IK starts putting a joint into the ground. Starts putting a leg segment into the ground. And then that leg segment can't really push back on the joint above it. Could it do that? Could it push back on the joint above it? Can I do like a double joint? So there's a joint that fixes this leg segment to this location relative to the body. And then there's another one that fixes it relative to this. Am I sure? Okay. Am I sure this is definitely right? Definitely correct. This is taking the body's origin point relative to the skeleton, so this becomes a global pose. And then I have to get it relative to the parent. So then I do that. Now a relative position. And then Let me just do this. Because it goes wrong so quickly, it may just be that I actually have it incorrect, because it hasn't even touched the ground yet. Those are all correct. Yep. I'll be right back. I'm gonna get it eventually. I'm back. Okay, I've got a... I'll give this one a good shot, but I have another idea. I'm going to move these and hit continue. So annoying. So annoying. So annoying. Okay, good. Got it. So there's one tick. They're already displaced by quite a bit. I am noticing that. They're already displaced by quite a bit. So now I want to... I just wanted one tick to go by. So I can look at this. One more. Okay. So there's already a bit of movement happening. Are these like... Yeah, these are... Okay, so these are nearly identical. I'll step down the line and see... Okay, so this one... That's pretty significant after a single frame. Maybe it is because it's not able to save its work between calls. Maybe this is it. Because I feel like this is definitely just too much. There's too much displacement already. It's in the air, no collisions are going on. All the bodies are just falling with each other. Okay, so I still want to see about the point that it just gets insane. Wait a second, last position is actually just stupid. Last position is actually not helpful at all. Last position is just always going to read the same value. Same with rotation. Rotation is just the rest rotation. These are just not helpful. Okay. Here was my idea. I know where the problem sort of is. The problem is in the bone that connects to the main body. That's where the problem is. If I push on any of the legs, it essentially does this, which causes rotation, or even not doing that. Just the leg sitting there will do that a little bit eventually in some direction, and then the whole thing twists and it all falls down. I do know that's where the problem is. So my thinking in that situation is, could I double the joints there? Could I just take that joint and just duplicate it several times? And then I would maybe I could still use motors. I don't know. Let me think about this. putting a second joint there would kind of, I mean, would essentially have the same result as doubling the physics steps for that joint. It means it could stabilize itself twice as efficiently, and it would transfer velocity through twice as efficiently. There's just so much. There's just too much that too many things to try. I want to stick with this one. I want to keep trying this one, see if I can make it work. So, the bone pose seems fine. This is probably where it's going wrong. I could do like, I could try this. I could go halfway there. Because as long as I'm getting that, wait a second. I can't move it. That's actually, if I do that, I literally can't move it. I can't move it. Yeah, so that's probably what was going on there. It was probably just like whipping things around at light speed because IK was. Like, what is has a joint's gotten stuck in the ground? I mean, I can change where it's targeting, I think, but that target can't move into the ground. That's kind of an issue. Because then it can clip into the ground. If I don't move the targets, then I can pretty much be sure things don't fall into the ground. And yeah, this is still a big issue. This happens. The first two joints look normal enough, but then the second joint is really, really bad. So probably what that means is I need to set. I think the issue is that the IK thinks this is the interior angle, and that's not the interior angle. The interior angle would be like translating this to match and then checking that. So the bone rotation would be I mean, I guess I computed it originally at the start. Wait, yeah, it's the bone rotation is wrong. I'm getting the offset. The offset is wrong. Huh. But this is what I thought. No, it would be maybe what I do is I keep the joint parent and the joint body. I change them back to how they were. And when it's running, that's when I change it to the main body. Let's say that whatever I do from this point on, I am purely doing it through code. I'm not going to change these structures anymore. Just got the wrong name. So I load the joint, I load it as it is. I get all the data correct. And then when it's an IK joint, I get these. I'm still doing caching, doing this. And then what I'll do is pretty much at this point, I say I've marked down those relative transforms, joint to joint. And then what I'm going to do is I'm actually going to change it. So node A will be there. Okay. It's a little bit, I mean, yeah, the IK's a little bit seems like more aware of what's happening. It hasn't glitched out. Leg joint has apparently gone into the floor though. So Also, I just think that joint is probably way too free. That's probably... It seems like this one's way too open. So... I'm gonna fix that. I think it's definitely more rotation than it should be allowed to have. I mean, what I think, like 45 down, 45 up, so it should probably be like 90. Yeah. Really? I can't make unique? Are you serious? Okay, I don't understand why that wasn't possible. Sure. It just seems stupid that I couldn't do that. I think it's lying to me. That's odd. I think I'm not being told the truth about something. Because these are all shared. Unless... because things changed that totally broke. And now the crawler bot uses unique ones for every one of these, which is, there's no way that's true. It is lying to me. There's only 2 up here. It is lying to me. Okay. I thought so. So even though those are definitely all shared, it's pretending like they're not, and also just actually lying to me and telling me that these are not shared when they definitely are. That's why you only use resources. This wouldn't happen if this was a... if this whole settings was a resource, it wouldn't happen. Which it could. There's no reason it can't. Okay, so I closed that up a little bit. I can't see anything. Can't see anything. Okay, it looks like it doesn't care that I just changed it to be 90 degrees. So we're still lying to me? Definitely. 100%. Because I should only be able to rotate down 90 degrees, or down 45 degrees and up 45 degrees, and it's going totally upside down. It's not possible. It can't do that. It can't do that. It can't do that. You cannot. Oh. Part of it is that these joints should not have any of this. These joints should not be allowed to move. At all.
Okay, so it's super wobbly.
Is it doing anything?
I wanted to see if it was going to, like, very slowly stand up.
Seems like I just can't quite manage that. Uh, that just shouldn't be happening. How could that be happening? How could that be happening? So this is joint 14. Okay, so these are very close together. 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 Okay, so these are That shouldn't be happening. That can't happen. All right. New plan. I really try to, okay, so just gonna comment out like this. And I will, and then it has to be tapped in because otherwise it's not happy. Rebuild joint using ideal IK results. Okay. When I build it here. So here's what I'm going to test now. I'm going to test duplicating the first joint and making it so that both joints are basically just like a centimeter up from each other, basically. Or I take the initial joint, I move it up a half a centimeter, I duplicate it, and I move it down a centimeter. So now I have two joints sort of in this configuration, which, you know, if I think about drilling nails into a wall, that should make it super rigid. And there's also two of them. So it'll be like taking the number of steps that I'm doing and doubling them. But I want to duplicate them in a very specific way because I know that the order of velocity constraints generally doesn't matter, but it does matter in the sense that if I operate on the first one and then I operate on the second one's not going to do too much. What I would like to happen is to operate on the first one of every leg in sequence and then operate on the second one of every leg in sequence. That's the order that I want to be in. So that means when I'm going through the list, I basically will go through so all of the joints should create initially. So yeah, they'll create initially. So it'll be all the first joint. Yeah, okay, so I'm actually already good. So all the first joints will be there, and then I go through them again and I duplicate them. So I basically take a copy and move it down. So I have all the first joints and then all the second joints. Okay. So I don't even have to think about that. Okay. At this point, I will copy these in. I'll just put pass at the bottom just so I can keep it around in case I want to bring it back. And then this is going to be a comment. So these all already exist. But I do reassign them here. So this is a reassignment. So I'm basically remaking the joint. And then I don't care about any of that. This is all that normal stuff. And then I'm going to do rigidity, I guess. So at this point, setting the node paths has reconstructed all the joints. This is set up, right? Yep. Set up and run through. And then only for the ones that only for the first ones. Oh, but before I do this, I want to I guess I don't have to move this down, but I think it'll improve. It'll make it better if I put them both on that Y plane axis, I guess, but above and below the midpoint of the body. Translated. So the Y direction is facing that way, so this is the Z axis. Moving it up slightly. I don't really have to do translated local because I already like that, so I'm just going to do position. Move them up before I assign the node paths. Then I guess it will be one of these. Duplicate flags 15. I do want that. Only properties marked for serialization. I think they are, right? If they are properties in this sense. Yeah, they're properties. Okay. So it duplicates those. So I duplicate this. I don't think it copies the transform. I'm going to I don't exactly know what it will do.
But I guess you said it's transform. Which position?
So then I move it down. And pair joint. Play anything else? I'm gonna say this. I'm gonna say move it down, and then I'm going to copy the node A and the node B. That should be it. So I guess I'll just double check that this works. That I at least get the right values. So joint data, joint. I'm looking for the angles. So this is going to copy the 30 and the negative 30. So it's going to look at what pair joint looks like. Okay, good. So it's copied that. All right. It's also copied the nodes already. But what's the transform? The transform is also already there. So I guess I'm curious to see what happens when I step over that. Does it modify that transform? It does not. Okay. So I can actually put this up here, skip that, and I don't have to do this. Because when I add it to the child, it's going to rebuild anyway. That's how these work. Joint 3D rebuilds when it enters the tree. Somewhere. There's the body exit tree. Enter tree. Update joint. That builds the joint. So I don't even have to, I just have to position it, and then I add child, and it's there. So I already see it detaching, which is not a good thing. Not good. Yeah, they've all, like, slipped and are dropping. So I just want to look at the remote scene. Each of the femurs should have a second joint. Yep. So I don't think I need the linear. I just need the angular. But I mean, I guess I'm just going to see what happens. So they are in like a very weird position. That is very strange that they had this weird position. They're like slacked. Why are they like that? I mean, I guess let me check this. Maybe this is like... Does this joint already have... Because if I move it up, then that means it's actually going to drop. So look at, I already have the joint. So it's pointing to these nodes, but these are about to change. So doing this is rebuilding the node, is rebuilding it. Yeah. So that's rebuilt it. Is it that it doesn't actually rebuild? Because it does do this equality check. Which I guess even at that point it would actually be different. So that's fine. I'm not doing anything for positioning this, right? I'm not doing anything on positioning. In fact, I really don't want to do anything on positioning. I really don't. Just return. And then... It should probably still work from this. But now bone position would be this. Swinging that location and putting it relative to that. And then this. Nodes are still like dropped dramatically. Why? They're already detached. Why? I would say I'm going to choose to ignore it for now, but that, I mean, it doesn't make sense. Why would it be like that? Okay. Let me pause right away. So I can see it's already wrong. Even the IK is wrong. Or do I not know what my skeleton looks like? No, that's what the skeleton looks like. Okay. Really? Alright, sure. So that's fine. They're in a good place. One frame next, they're not. Is it because they don't have the right exceptions? I think that's it. I think they don't have the right exceptions. So, exclude bone from this parent physical IK if it exists. Which I mean, okay, so there's that. Oh, it's the collision exceptions. No, it's not. No. It is, it's not this exactly. If intersects main body, I still want to do that. But I'm going to go back through this and turn all these back on to exclude their bodies. And then this is one where I don't... Yeah, if joint data parent is equal to main body, I'm just done. I'm not doing this extra bit at the bottom. Let me do this. This would be smart. Yeah. So if I want to go back to test the other one, then what I do is I'll write some code to turn this off and then correct it if it did. If it does already do it before I even get to call it. For 5 milliseconds. So then if I don't do that, I'm actually surprised that it even stayed upright in the first place. And it didn't fall over immediately. Same thing, right? So now, here is the ultimate question. What if I don't do this at all? What if I always do it? Okay, it matters about the angle, so if it's on the X, then I have to do it along the X-axis. If it's the Y, if it's the Z, then I have to do it along the Z-axis, right? So I mean, I guess it would just be like doing okay. Double joints. This feels so... This makes me feel like an idiot. This makes me feel like an idiot. I feel like I'm stupid that I'm just not trying this. Activate the motors. The motors will do the calculation. They only operate on the main joint. Should be good. I mean, it might be broken. It's still drifting. What's going on there? I have to turn the motors on. So here's the idea then. When I duplicate I make sure that specifically any motors that are turned on are turned off when I duplicate. Because otherwise that motor is going to be like resisting rotation, and I don't want that. So when I duplicate, I need to turn any motors off. I'm going to turn off motors and springs. So make sure all springs and all motors are off. Well, no, I'm just going to turn off motors. I don't think I'm going to use springs. If I get there, I might, but I don't know. No motors. So and then in here, they're all shared joints, so I only have to modify the first three. So this one has a Z motor, and I will limit this to, I'll start at 50. 50 is definitely more than enough, because the whole mass of the thing is like 40, so 50 should be way more than it needs. Right, and then I have to make sure I turn them on. They're turned on. ZZXX. Okay. All right. But it's like it's still staying together. I mean, okay, I see these are definitely like torquing pretty bad. But it's roughly staying together. The angular limits are definitely copying. Technically, these motors are also, you know, not even good either. These are really bad motor values. It still fell over, though. It did fall over. So how is this swinging? That's what I don't get. How is this swinging? It is specifically when the motor is turned on. It starts to swing. Okay, I want to see this. So I've got, which one is this? Middle left. I'm just looking at all the middle left. So what are the joints trying to do? So I'm thinking what's happening is, yeah, this one is trying to... Yeah, the Z motor is kind of going haywire, right? Oh. How long has this been a problem? Negative 5.7296. $5.7296. It's not a problem. Okay, so the shared Jeez. This dog. If we're not running the editor, skip. If we are in the editor, do this. Okay. Okay. Let me do like a print. Okay, good. They're okay. They're operating individually. I thought that was a mistake where I was copying everything over at the same time. Okay. Let me change the torque to be unlimited because it looks like that's the issue. It looks like it just can't make the torque work. And also, I mean, maybe I let the velocity go really high too. Because the idea is that I'm trying to complete that in a single tick. So at the very least, the torque needs to be high enough to stop itself from rotating quickly if it wants to. So let me just drop the torque limit on the femurs. I mean, it's still pretty wobbly. A little more stable, though, I think. I don't know. Is it? It's hard to tell. I think it may be that it could just be too sensitive. Or maybe the max velocity needs to be even lower than this. Or higher. Okay, too high. It like basically, yeah, okay. Too high. I mean, it could also just be an issue that, you know, the legs aren't being, don't have any resistance along the ground. But I've got another idea. Doubling the number of joints seems like it didn't do anything to the physics except maybe it's made it more stable. I mean, it should. In theory, it should, because it's just like extra iterations that I can run the whole way through. So I'm going to make 3. I'm going to make 3. I start with this raise, and then I'm going to do this twice. I'm just going to literally write it out twice. There is still a lot of it, which is really sad. There's still a lot. Yeah, how about this? How about instead of translating them, I just like am literally creating several copies in the same location? What about that? Let's just go wild immediately. Make 4 of them. And all I do is I turn off the motors. It seems like nothing's really changing. I was running at 6 milliseconds though, so I was running at 6 milliseconds. I don't know how it could be standing right now. Very weird. I guess every leg is trying to take a step right now or something. I'm actually still like right at 4. So what if I don't do any? Oop, not 9. None. I don't do any. No, I don't get it. Okay. Wait, yep, the leg is falling. That leg just basically totally fell over. And then, you know what? Let's just go to crazy place. Put 10 in there. I mean, at some point there should be a difference. And if there's not, then it's like it's not even doing anything. They're still just really wobbly. Yeah, I don't think I need to go so far with anything but the first one, honestly. Okay. I just totally exploded that leg, didn't I? Um, what am I looking for? Uh, So the idea is I'm moving it along. What if I actually just had two joints that were really far apart? So consider that the width of this is 6 centimeters. I have one joint over here, 3 centimeters, one joint over here, 3 centimeters. What if I did that? I mean, like, in my mind, that means if the joint is as strong as, basically as strong as I give it to be, and I put two joints really far apart, they could both apply like really high corrective forces, right? Because it's more like they get 16 attempts to apply their corrective force. And the further out they are, the more they're going to do. Because they're going to see the body rotate a little bit or move down a little bit. And it's going to be like, okay, this is really bad. So we got to slam it up, right? So it'll really... I feel like it's kind of trading off. Not really. It might do very well for rotation to just have two joints, split them very wide. So this is 6. This is 8. This is 12. So I could... just keep widening. How would I specify that? I can't really specify that in the IK chain. I could just start by saying like the total width. So then I'll be able to test it. I mean, yeah, like as far as like engineering goes, you would prevent them from torquing by like having a very strong steel rod, which would essentially apply a point here and a point there to twist on. Which then actually spreads out to the whole body, so if it's all welded, then it's like 5, could be like 10 centimeters apart. I just hope this is actually going to be doing something and I'm not just going crazy. I need to give this a default value. Let's go to 4. Well, actually, it'll be the width, so the total. So I'll say 8. 8 centimeters. I can combine this all. Then I need a step. So I guess I can just say if count continue. So I need to do, I think it actually might just be as easy as doing the width divided by that. Because yeah, if it's 1, then I want to do full step. If it's 2, I want to do half half. If it's 3, I want to do A third, a third, a third. Yeah, okay. Let me just try one on everything with this 4 centimeter. Okay. So what if I did something very ridiculous? Okay. I mean, 10 centimeters is pretty ridiculous, right? Okay. Let's go for 0. 0 should just do nothing. That also can't be 0. That's definitely, I mean, it still gets into like that really bad, I don't know what's called. It's like a feedback loop, I guess. But it took longer that time. And if I just had no copies. I don't know. It looks different every time. Like, that's the thing. It looks different every time. You know what I think is happening? I think it's actually able to lift this leg and it tries to take a step. And then it... then it kind of goes crazy after that. Here's what I'm gonna do. I'm just gonna let this go. For a little bit. And see what it does. Because I wanna see if there's what is the performance hit on this, essentially, is what I want to know. What is the performance problem? Okay, so it's really sitting around like 3.5 with all them running. I change this to 0. I run this. There goes a leg, just permanently falling over. Okay, so it's at least good to see that adding the 1 has done something. I've seen that leg just fall over every time now. And strangely, like, I don't know why, it's sitting at a higher... I mean, it's the same. It's done, like, nothing. It's done almost nothing. Let me do this. Let me put it on the turntable. Well, so I'm not really sure how it's turning. It shouldn't be turning, I think. I don't know if I put that in there yet. I think I took that code out and I haven't added it back. This is still with nothing on, right? Well, none of the legs are falling over, so it might be on. Yeah, the legs are all... It was actually off. I think this is probably solved with getting the legs to have like a frictional impulse on the ground. So when they are dragging, they are, or when they're sweeping like this, they're actually dragging and stopping themselves so the motor can kind of do what it wants to do. And it really doesn't seem any different on performance. I guess the issue might be like when its leg is lifted, the rocking is probably just too much for that motor to deal with. What if I went really crazy? 20. Something absurd. They still swing really badly. Yeah, it seems like that unfortunately has a... Well... Hang on, let me look at this. It actually does look like it's this joint that's swinging. Yeah, it actually does look like it's the other joint that's swinging the most. So what if I just slowly turned everything up a little bit at a time? Or if I made them wider? Interesting. I feel like it's not really... I mean, it's done... It's like there's really... Like the graph of like value is like 0, 1, 2, and it's like a flat line instantly. Like it hasn't been helpful at all. Because I'm looking at that first joint is turning so far over to the side. Would it really just be fixed by... I guess here's the thing. When it lifts up the leg and it tries to go forward, that back joint is going to kind of fall behind and then swing in, right? This is the back joint. The last joint is going to fall behind and swing in, and then pull it too far. And then it's going to try to pull back, and then it's going to pull it too far. And it's going to try to go forward, and it's going to pull it too far. Right? Like, that's going to happen at high speed. That's going to happen at high speed. I would need, like, a really, really strong joints around there to stop that from happening. Adding more... I mean, to my understanding, adding more should be making it better, but it's also not. It's not really enabling more velocity transfer to happen. But it's at least creating them, I think. I think it is creating them. Because if I set it to 0, I will see a leg fall over and it won't ever come back. But I thought this would be like, this would have the effect of multiplying the number of steps every time I add one of these. Like if I added 4, then I would be at 4 times the number of steps. Which I know that 1 is sufficient for, I mean, I bring it up to 80. I'm just gonna do 5. I'll bring it up to 80 and this is gonna be like pretty rigid, right? With 1. I can even see that the frequency of this is way higher too. So how come adding the extra joints has not done anything? Because in theory it should. As long as I run through the entire list and I update all of them, which is what happens, it's like that the entire thing is updated. And then I basically just run through them again. I run through the exact same joints again. So to get 80, I would have to create 4 copies. And in theory, like if I set these to 0, which I'm going to allow myself to set them to 0, as long as I don't divide by this value, which I definitely don't, I just use this as a multiplier. Yeah. This should have the same effect. And it clearly doesn't. The frequency is way higher. Or lower. It's like big swings. 80, it's very small swings. So why? Are they being ordered? Technically, these do have priorities. Godot just doesn't allow you to set them. They pretend like you can't, but you definitely can. Why would it not be the same result? Yeah, the effect is the same because I would run through all of those constraints and then run through all of them again. But if it's sorting them, like I think it might be, where it's essentially doing I don't know, like it's starting with the body with the most joints on it, and then it does all those joints, and then it goes down to the next one, does all those joints. That wouldn't be good. I'd want to go through all of them and then iterate through all of them again. So set up velocity constraints. So velocity constraints. I guess the idea there is that if it does any kind of sorting, which it should do a little bit of sorting. Because I can provide priorities. Active constraints. Why would it be different? Why is it different? I have this open twice. S solve velocity constraints. It just runs through them. Um, I understand. I can't think of why it would not be the same effect of just using 5 of them. If I run one with 16 steps, then running 2 16 steps each should be the same as doing 32. It should be. If I had 3, it should be like doing 16 times 3. I don't know. Oh, I just went totally crazy. No. It's like the first copy exists and then it's done making copies. What if that's actually happening? What if it is actually just making one copy? Nope. There's tons of joints. They're all running. Okay. The only way I could see that meaning something is if it was running like the same joint 4 times, right? Like, okay, let's run you. All right, let's run you again. Let's run you again. Let's run you again. Because what's going to happen is the first one's going to do like all the work and the next one's going to do a little bit more, but it's not going to be getting any of the feedback from all the other joints that are being processed. So it's just going to dial into what it should be. So it's like going to be an unstable result, I guess. And then the next one's going to run like 4 times. Like that would be a problem. Two-body constraint settings. Two-body constraint. Constraint settings. What's that? What about this? What if I just unlock the velocity position steps override? And just for that, for the first joint, it can do way more. Or, I mean, it can just, I guess it just go back to the priority where I set the constraint priority. Let me try that. Because I can set a unique one. And it says if I give them a unique priority, they have unique ordering or deterministic ordering. So joint set solver priority, joint get solver priority. Or get solver. It is supported. So I'm going to make it supported. It is technically an option. What would it be? Is it like, what would this be? Joule to ref? Okay, so it's Joule to ref. Okay. I even see this up here. Set num velocity steps override. Velocity iterations, position iterations. Where does that come from? GPHU int. Iterations changed? Set solver velocity iterations? I mean, these exist, but you can't access them. Like, I don't understand what the point of these are. Why do they do this? Like, you can't. Why are those there? Nobody uses these. Nobody can use them. Why are they written? It's very silly. Um, I guess the question is like how data enabled. Like how does it pass these on? Maybe it doesn't. I don't know. Because the thing is, these don't exist yet. Also, what these call body adjoint this? What? Why does that happen? Jolt body 3D. Why do these have to have an adjoint? What does that do? Update joint constraints. Sure. Is there a namespace there for that? It's really weird. Process iterations change called. Nowhere. Okay. Good. Set constraint priority. There we go. Set constraint priority. Okay. Now, when they build, yeah, I want to do m constraint priority equals whatever, right? So rebuild on this one. It's configure joint. Is it configure? I think rebuild. Yeah. Okay. Joint. So wait, where's where does it set the solver priority? Joint get joint set solver priority. Joint 3D. Oh, it calls configure, then it calls joint set solver priority. Okay, so I don't have to worry about that. Yeah, I don't have to worry about that. All right. Cool. Okay. Set passes through correctly, so I don't have to do that. I don't do that here. Not doing anything there. And then it passes through. That should be it, right? I just had to add those calls, and that was it. file. They declared it. Yeah, probably. I probably could have left Godot open and like typed it in to start to have the code ready while this is running. Oh man, really yawning. Still got coffee. So I don't think it matters like if I set the root to 0 and the end to a high number, or the root to a high number and the end to a 0. I'm just gonna count up from a number. Every time I see one, I start with a number and I just increment it so that they all should run in that order, and I should really get a performance impact, and having 5 joints at 16 steps should look the same as having 1 joint at 80 steps. It should look the same. And if it doesn't, that's it. I'll be done for today. It says higher numbers are more likely to be solved correctly, which means they run first. So maybe I should count down. I'll make it equal to It's also a uint, which is doing a static cast. So I could actually just count down from -1. The wrong way. I'm supposed to do scrap the solver priorities for now. So what I mean to do is what I mean to probably save the number that I'm doing. So I need to have an outer loop that's the count, and then an inner loop that goes through the list to do it. But I don't want to just copy it. Whatever. then that's not actually happening. Joint step is float count. So now I'm adding these in the right order. And I'm just going to print it out too. I'm just going to print duplicating joint and then the name of the body. I'll just put in duplicate joint. Yeah, I'll put in duplicate joint. Okay. Front left, front right, middle left, middle right, back left, back right. Huh, alright. Maybe the way that I really want to do this is step through the max number of times. Because I want to run the whole chain like that. Okay. This makes more sense. Okay, so both situations are handled. And then this... Multiplying it like that. Otherwise we're multiplying it like this. Front left, femur, front right, middle right, back left, back right. And then I saw front right, back right. What? What? What is this order of printing that's happened here? Why is it such a weird order? The front left went through, front right went through, middle left and through, then middle right says front right. Do I just have typos in my names at those points? The middle right tibia is still called front right. Okay. And back right. I feel like I fixed these. Did I not? Can I have the right names? Okay. So whole every leg group there. And now if I were to add one, let's do like this. See what it does. So it says we've added it in this order. Then front left to back right, front left to back right, and then I do all the femurs one more time. That's great. Okay. Now what does this think about performance? What do you think? I still see a really high, it does not look the same. But I mean, I guess that like this was the idea, and then I would probably use like 0.12. So maybe now that I'm just constructing in the right order. No, it's still very wild. Okay. Okay, well I have priorities, so I'm gonna stack priorities on top of this. And make use of the fact that negative values should run through correctly. It just doesn't look the same. It's not what I would have expected to see. Like they're... I mean, this one's maybe not so easy to tell. What if I did one copy? The thing is, I'm seeing the legs like make steps. One of them made a step. Sort of. So it just doesn't work no matter what way I do it. What if the cast just makes them all the same? Like, I still don't see a performance cost to this, which means it's not doing it correctly. Whoa! Too many. Too many. Okay, so that was actually the first time I had a performance cost. But I also feel like it was because it's still not actually doing anything. It's just spinning through the loop and not doing anything. $50. Lag. And yet it still looks like it doesn't do anything. It still looks like nothing happens. It's just as bad as it's always been. Even though this number keeps going up, it's just not... It's not doing anything. And I feel like I have so many joints lined up that there's no way it couldn't be, like, passing all of the velocities through. Because the result is the same as if I really was running through the whole thing and then doing it again and then doing it again. I think I know the difference. The difference is that that internal tracker for the force is not shared between the different joints. So basically the first joint goes in, the first joint gets its one iteration, and then the next joint gets its one iteration. So ultimately the same joint still gets the same number of iterations. But then I don't it still doesn't seem to make sense to me, because if we run through all the legs, that other joint on the same leg is going to go in there and read in, it's going to see all the velocities, right? Look at this. Okay, so I can't just do it myself. That's what I was going to look for. And I see something that says Contacts Manager, so I probably don't do that. Okay, so the alternative is I can... Is it possible to get the same joint to appear in the list twice? Is that possible? Can I do that? This does the S solve velocity constraints, constraint manager. I'll just find it again. What? Is this the same thing twice? Yeah. How does it know how many to do? That's the question. If I have an override for how many to do, does it just mean the entire batch runs more? Get num velocity steps. Yeah. It leaks. So if I have a group and one of those joints has like 10 or 30 constraint steps, it's gonna leak and cause everything is connected to run 30 times, right? Which I guess makes sense. My thought there was I would just have that first the first joint around the whole body would run twice as many or something. I mean, I guess what's the difference between making multiple joints and just having the whole set run 20 instead of 30, right? Okay, that's gonna be it for today. The one where they have the static thing doesn't work because I can't teleport them. I can't move them. Moving them causes problems. Even like reconstructing them just still does it. It just causes problems. They'll slip through the ground or whatever, right? All right. I just got an idea. What if I used... okay, so I have the normal joint chain. And then I had like a slider joint that would be locked in to matching every frame. I would just set the angle that it can be locked to, and that is connecting the main body to the other two joints. Actually, I'll just say that it connects to the other two joints. In fact, maybe just all three. So the first joint is going to be connected as it is, and then every joint after that will have another slider joint that connects back to the main body, or just connects back to that initial force point. So on the leg, it would go in, this connects back, this connects back, and this one connects back. And it's basically like I would take beams. The idea is that I would take like beams and slap them onto the side of the leg and where it connects. And the idea is that would transfer any torques like this directly to that body piece. And it would be it'd be a slider joint, so during a step it can expand and contract. It could pivot left and right, but it can't do this. It can't rotate. It can't spin. So that would be like having 1, 2, 3 more joints per leg, purely focused on maintaining a balanced Y rotation. I like that idea. I'm going to keep it in mind. I'm not going to do it today. I'm going to do it tomorrow. That will be the first thing I do. I'm going to open it up. Open up my to-do. Put it here. That's the idea. As soon as it opens. Okay. Update their Z rotations to match not really unlimited, but allow plenty of pitch and length. This effectively adds 3 more joints relate to control and ass, yaw to the main body. Give high priority so they all act before regular joint corrections. So basically, it'll be like 1, 2, 3 joints will do their best to snap the leg into place at each segment of the leg, and then the whole leg would, or rather, since they would all have a high priority, every single leg will try to snap its yaw to the body, so the whole body gets that, and then the individual joints will move up and down or whatever, and then that would just happen again for the next iteration. They all try to snap their yaws, basically, is the only point of it. So slider joint should basically be like moving like this, and I would set the target rotation to match the Z, and then they just can move as far back and forth as they want. It's just that whenever it torques, it's gonna fix that, right? And who knows, it might even be enough to only add it on like the last limb, so the last 2 joints. It might even be enough to do that, but I feel like doing the third one's probably just gonna be better anyway. Okay. That's the idea. All right, that'll be tomorrow. So, thanks for watching, and I'll be back tomorrow. Goodbye.